we've worked incredibly hard to say give the developers their tools and give the business user their tool with no code.
Welcome to the third video of the 1ClearThing series. Today we continue our conversation with Aaron Allsbrook, the CTO at Clearblade. Last time we covered the technical challenges of building scalable, secure and cost-optimized IoT platform. How customers can leverage those assets in their business operations. We touched on the edge devices and application layer, but those topics deserve more attention, so we will extend them today. Hello Aaron, it's great to see you again.
It's great to see you too, Kash. Thank you for having me again.
Before diving into the main topic, let's set the scene by explaining the concept of edge computing and why it's so important for IoT solutions.
Yeah, edge computing really is about being able to do some of the processing, some of the logic, some of the ingestion in the remote location. That remote location in our industry today can be all the way down to a truck itself in the field. It can be at a pump. It could be even at maybe a 5G antenna, or even sometimes it's called an edge can be kind of a remote data center. We see that in telecom a lot where they'll call an edge a remote data center. But pretty much if it's not in IT and in those servers and it's not in the cloud, that's now the edge is how we look at the world.
We've got a number of different edges, so to speak. We've got edge gateway servers, which are pretty significant piece of hardware. And we've got those small constrained devices that are also the edge themselves. There are multiple layers of edges and we'll cover them today. But the T in IoT stands from things. And in my opinion, working with applications and backends, for sure, working with cloud backend is way easier than with actual physical things. Because it is pretty easy to break them and pretty hard to fix them remotely. Things actually open new attack vector for hackers. So how do you protect your devices and data they gather from unauthorized access?
So what we've done with an edge is we now have moved compute to the location. We've made it available to a whole world. Hopefully there's a lock and key around it. Now, we hardly ever think about having to lock the door on our servers, but you definitely have to lock your door on your edges, so to speak, to keep people out. We love the edge because the edge gives us the ability to talk to all the protocols, right? So the edge is going to unlock what is currently locked data by our machines. We love the edge because it's going to let us make decisions faster. That means we'll be able to get the data, make a decision before having to go to the cloud and pontificate over there in those servers and send it back. We like it because it gives us offline support. I love it when the internet's up, but the cloud servers go down, the internet goes down at times, and you still need your factory to run. So we love the edge for all those reasons. And we love it for security, the fact that we can do things and actually leave the data in the field. Often, sometimes taking the data, putting it in transit, letting the cloud store it, letting the cloud copy it, can sometimes create some security vulnerabilities that you didn't want to in the first place. So there's actually some added security by doing this just out of the gate. It's great when the images of my face don't go to the cloud. They can stay in the store or stay in the building. But you do have to think a lot about security. And one of the big challenges is when you do put that edge computer, especially when you're talking about in the IIoT, the industrial area, much of the stuff you're talking to doesn't have any security, or the security model is from 10, 15 years ago. A lot of security 10, 15 years ago was air-gapped, meaning it didn't connect to the internet, and that was a great solution. And then also obscurity. It was just too hard to figure out how that data was getting transmitted. It was ciphered or whatever else. And so those two things are not adequate anymore. People can, force their way through. They can brute force their way through any sort of that kind of obfuscation that may exist. So now it's more about how can we bring these IT security practices and drop them in the field, whether it's the network practices, right? How do you ensure the security of the network, whether it's port blocking and making sure you only have the right actors, whether it's VPNs, all of those things begin to show up at the area. But also you have to now think your application, your edge application maintains responsibility for protecting those devices on the other side. So now you say, okay, that means the core principles encrypt the data. Just because the device didn't encrypt it, it's now the edge's job to make sure before it sends it into the internet, it's encrypted. It's now your job to make sure that device and users of that device are authenticated. Do they even belong in this? There's some great security models for different ways that we do authentication today. Whichever one of those is, you want to move it down, whether it's OAuth for the users, whether it's MTLS for the devices or asymmetric keys. That pattern needs to be brought to the edge. So we'd really need to see authentication best practices moved. That's a hard challenge to move that down there, because now you're putting, what are complex business processes served by, large SAML servers or OIDC implementations, and you're dropping that on a Raspberry Pi. And then you have to have the authority model in place. Just because a device is connected, is it allowed to see your social security number? Probably not, right? Because every device could be compromised. So you have to build the entire security model that you would have thought about from a centralized server. And now how do you distribute that down into that local place? And I'm not even touching the hardware, the root Linux access. There's a bunch below that too that everybody has to be involved in. But for me, Edge is about processing. It's about getting the IoT data. It's that application side. So our responsibility, and anyone who's building an Edge application, their responsibility is to handle those pillars of security. And then you do things like the audit trail. How do you unwind if something did go bad? How do you build that audit trail? What do you sync to the cloud so you have it in multiple places? Those become really, really important as well to begin to undo and understand what might have happened in worst case scenarios. So that's how we approach Edge in terms of security, right? Lots of benefits, new data getting in, processing speed, offline capability, but then you got to basically bring all your best practices of application security and drop them right in that environment as well.
You covered tons of things, and let me decompose a few of them because they are extremely important. First of all, you said that there is no way to lock down Edge as we've got the data centers, for instance. Like there is no way for you to go to the data center and store a hard drive. When we talk about the edge is exposed, right? Of course, we try to make it as secure as possible from the physical standpoint, but at the end of the day, the edge is exposed, and you need to mitigate those challenges, like someone is trying to break that whatever device it is, right? They might try to break that device in order to steal the data, or maybe in order to penetrate the whole system. And as you said, just because the device is connected to local network, it does not necessarily mean that it should be able to allow all of those other systems in place. I think that's extremely, extremely important. And the thing that you also mentioned, that you provide that audit trail, like, to be honest, based on my professional experience, there is no such way as fully secure system. There is always a way to hack into the system, and even if we check the history of greatest incidents, there is a way to hack offline systems as well. So could you give us some more details on that audit trail and how you show what's going on into the system, so the IT department, the security department of your customers have got full insights of what's going on?
Yeah, so it's interesting, right? So, I come from an IT. A lot of my work was done in the IT world, and I've been fortunate enough to learn a ton about OT. I'm always learning in that. One of the things that OT did incredibly well, which I think IT may have been behind on, right? I complimented IT for all their security practices. OT is building audit trails and log files for a long time, right? Essentially, these devices have sat idle by themselves in the field doing their jobs. So the only thing you really knew about if they had worked correctly was to go plug in a USB key and pull these logs, these audit trails out. So it's actually, there's a lot of maturity in that part of the space. But essentially for us, and any application would do this, there are a set of transactions. A user logs in, a user turns something on, a user calls this API, a database is updated, a piece of logic is run, a message broker receives a connection, even down to the number of messages that are received. You can actually store the message history as well. Again, all of this is disk cost, so it's going to depend on the profile of the hardware. But that's the set of history and audit trail that you want to keep. In essence, you want to be able to replay what happened from that audit trail to understand what happened. That could be, if the privacy model allows it, that would be down to every payload of every API call would all be stored for historical measures. There's lots of strategies too to make sure that your audit trail hasn't been corrupted. Again, those are areas where OT actually has done an amazing job And I've learned a ton about, what a great idea and a way to be sure our audit trail can be trusted as we bring that back into the cloud or in other places. So that is an area. It's interesting. I've always leaned hard into those security pillars, and I've seen audit trails and stuff in IT, but at OT, it really made a whole lot more sense because of the offline nature and the physical vulnerabilities. I mean, our homes are good examples. We all have, high-speed bandwidth in our homes. Those companies are helping protect us from the outside world, but if somebody walks in our door and plugs a wire into our internet, they're behind the firewall. All of our home devices are open again, right? So that's really the challenge you're having to think about with the edge and OT is that what if somebody plugs in to what's going on directly?
I'm also from the IT background, and a long time ago I used to think that IT is the modern way of handle things and OT is very outdated, though there is a huge difference in mindset, because if I break something in the IT, I can fix it, and everyone is kind of accustomed to breaking things in the IT space, but OT needs just to work, right? Like it needs to work all the time, and it is actually pretty damn difficult to make it work all the time, right?
So it's very hard. They've done a great job to get us here for sure.
Exactly. So as you said, it's not always one way that IT force OT to be more agile, but also we need to respect the OT constraints and implement them in the backend itself. So I think that's a great point, and that you implemented that mindset in the ClearBlade. That shows that ClearBlade is basically industrial IoT ready from my perspective.
We've had the benefit of having a lot of customers who, we've worked very hard to make very happy, but also have done a great job of teaching us these real world constraints, right? So this is not something that we came up with or read in a research paper. This is how this works in the field in this location, and this is how the process works, and you need to meet it in there where they are. That's a great point.
Exactly. So speaking about how things work, ClearBlade manages huge fleets of IoT devices, and synchronization and state management, those are significant challenges when you operate those fleets. So how have you implemented those functionalities within the ClearBlade?
We tried to bring practices for how we do a lot of the cloud work today to this orchestration, right? If you think about it, the cloud it's hundreds of computers, right? Even though they're all in one place, to me as the user, the IT operator, I've got lots of different computers. And we've tried to think about how can I quickly just put what I want, logical behavior data store somewhere out there and kind of handle that for the user. So the same way I don't really worry about where a cloud function runs. I can basically create that cloud function and then just say make it available. So if you look at our architecture, the way our edges connect to our IoT enterprise offering, essentially there's just going to be policies that say this edge needs to keep this bit of logic and this data up to date. And so if the logic for how the application should behave changes, we'll automatically just update the device and it'll start running the new version of the software. It's nice when you have these massive rollouts and you kind of control things, but sometimes that's just too slow and often too heavy for a lot of where we want to go, right? It's incredibly compelling to hit save and the computer thousands and thousands of miles away now is just running that new logic, right? Now it's dangerous. You got to do the QA and test, right? You don't want to break everything that easy, but it is really great when that policy allows for moving that data and updating it if something does go wrong very, very rapidly. So we provide a sync mechanism that does that. So if our edge is running, it really handles getting the messages updates to make sure the same way IoT data transfers information over telemetry, we're doing the same thing for the actual application structure itself in real time. And so that's very powerful for many folks who are just trying to keep their application up to date. Obviously, our edge binary is running, and actually there's all these sync messages that are going on. Just like if all of your devices turned on at once and they all messaged at once, you could overload your server. So you have to build kind of almost your own staged throttle pattern for how this rolls out. That means that if you do update some logic in your application that's going to roll out to 25,000 edges, you have to expect that logic to kind of move across the network. The ones that are available first are going to receive it first. They're going to confirm they got the change. So we build that kind of rolling pattern. We don't try to burst everything at once. We also let the edges, we put some logic in that allow the edges to choose when they're ready to be able to take updates as well. So just because we updated the cloud, We want the edge to be able to say, okay, now I'm in a state where I can do this update. I'm not doing critical processing. That's also a big part of OT that us IT people don't think about. We think about just pushing Windows updates or whatever. You can't just do that, right? You basically have to have the edge ready to, in a moment of processing or whatever it's doing, to be able to take that update. So decoupling the update schedules of the cloud from the edge is also really important, even if there's new features that they both wish they could use. There's a lot going on and thinking about how you roll it out. And yet again, there's an audit trail to that. Every time you send a sync message one way, somebody needs to confirm this message was correctly synced, because if the data gets out, then you basically have an integrity problem in the overall application. And that's a whole nother barrel of what could go wrong if the edge goes offline, too many messages build up, it's beyond your policies for how long to hold it, right? You build these applications for best case scenario, and then you go back and solve for worst case. And a lot of times, how do you sync a long off time history and stuff will come up as, all right, what do we do in this case for this particular location?
That's a great point. Best case scenario is very rare in the actual IoT deployments, because real life is way more difficult than what we can predict. And what you said is crucial. Just because the cloud backend or the backend itself wants to update edge devices is not enough, right? The edge device needs to be ready to be updated. And as you said, if you're in the middle of production cycle, probably you don't want to mess up with your equipment. So the edge needs to be able to confirm that it is ready to update it, or provide a reason why the update needs to be postponed to some later stage. That's extremely important, especially in that industrial IoT, but I see that pattern over again and getting a bit more popular in other areas.
Yeah, our phones have taught us a lot about that, right? How many times do you say update later on your phone, right? You know you want it, but not right now. Right now is not the time. So, but unfortunately there's no user on the other side of these edges. So you have to let the edge figure out where it is in its cycle and put that logic in. And so you kind of have that autonomous mobile user on the other end.
That is correct. And that proves the importance of the logic that runs at the edge, right? The logic needs to be sophisticated enough to understand its current state and to understand what's going on around it before it can actually accept that upgrade. Because even if you've got that backup mechanism as discussed last time, the upgrade takes some time. And there are processes that are real time, and that small delay in the availability of the edge might be really bad thing.
There's other challenges too, especially with networks. Not just that networks may be slow, but you may have all the devices on one network, and if you update all the devices at once, you're going to swamp the bandwidth, right? So you got to protect all the other data moving around. So there's all sorts of reasons to have the ability to flexibly slow down the rollouts and the updates, and other times you want to mass force everything to go at once. It just depends on the constraints you're under.
I've seen a production line stopped because someone pushed upgrade and they used all the bandwidth of the factory. And that basically created a critical incident, which was pretty painful for everyone. So that's that thing, right? This is the edge thing part that we typically don't worry when we work with applications in a cloud, but in the edge, things get pretty real very soon.
Yeah, if you look at like some of these places where they have the Purdue model and they've built very tight infrastructure, they've thought about all that already. But now once you open it up to the whole world, we're back to application engineers being like, whoa, there's constraints I never saw. And so we still have a lot of people, thankfully smart people helping protect this stuff, because the policies aren't in place yet. And so it takes smart applications, smart developers, people who understand what the real constraints are to even protect it if the protections aren't there.
Exactly. Connectivity is one of the critical matters in IoT deployments, and Clearblade is protocol agnostic in terms of communication. So how can you even implement protocol agnostic platform?
We came at this from a kind of an IT approach, right? That was our background, and one of the things that we had been doing for a long time, and my background was a lot of protocol conversions. So the idea that you could have, a different database driver, a different socket type, a KIX transaction on a mainframe, an RPG service on a Series I, right? All these different types of sources had existed in IT. And we had worked very hard to, move into this API world we are today. We tried SOAP first. It was too complex. We got to this kind of JSON restfulness, and we're all been all very happy. So we came out of that world. Today, I'm amazed that there's like whole products worth billions of dollars that all they do is just kind of convert this on the IT side. But it's a model of essentially how do you bring everything into a common format in a bi-directional way. So when we started this, we knew, there will never be, Aaron's prediction, there will never be an IoT protocol, right? There will be many, many IoT protocols. There'll be many legacy ones, and somebody's always going to be creating a new and better one for a certain use case. So the only way you can begin to even understand how you work with this is to say everything has to have bidirectional communication. It's a mapping of the actual data structure, and the protocols become agnostic to the data that's flowing over them. So that's how we approached it. We basically connect the protocols such that everything flows in the same way. We then will normalize the data so we can look at it the same way. And so if we change it in our common structure, then we'll actually turn it back into the native structure. We're not the only folks that kind of do this. There's some other standards out there, especially in the OT space, trying to provide ways to make Modbus look like OPC-UA. But that's what we're doing, and that's the core structure, why we built this, right? Receive the data, normalize the data, process the data, why we fused our engines together like we talked about in the previous session. So with that architecture in mind, then what you do is you spend your time of how to make it as easy as possible to ingest a new source, a new data source. So once you've got your head protocol, data mapping, then the abstraction becomes pretty transparent down to where you can do new protocols you've never seen before, or maybe new types of devices in an hour or two. I think we're going to move that even further with our next session topic about AI. But for now, you can have a developer who bumps into a protocol they've never seen. As long as it's a little bit documented, they probably can get that thing flowing very, very quickly. We still have a lot of undocumented proprietary protocols. Thankfully, often those can be reverse engineered. Those are all done per customer who own access to that protocol. So the model works for both open standards and non-open standards. Again, the IP related to that ends up belonging to the people that look at that data, not Clearblade. But the model works for both to unlock wherever the device comes from. So that's how we took an agnostic approach. We kind of do the same still to IT. I look at a lot of these tools that are like, we'll convert your Maximo to your ServiceNow and that kind of stuff. And that's similar to what we're going to do for the IT side. We're moving this data back and forth across these X crossing domains. Well, then you've got to be able to do it for both sides. So that was the agnostic approach to devices. Again, bring it all to a common and then unpack it back into the local. And with the edge, you can actually do the normalize and denormalize there locally in the home, in the building. So that's where an OPC-UA device talks to a Modbus device that updates a LoRa network that then turns on a Bluetooth sensor. One little pie can do that sort of relationship in a little bit of development time is very, very compelling.
Yeah, that's the beauty of IoT deployments. And speaking about customers and moving data around, what are the business and operational benefits of integrating Clearblade into other systems of the customer?
We try to reduce process and operational costs, but we try not to change the investment in the processes they have, right? So if today, an alert goes off and then they open a ServiceNow ticket or they update a Maximo asset or there's a big database that gets trained for AI, if they've already made all those decisions, that means they have processes in place, people to work with it, expertise in the software and the domain. So for us, we say all of those applications can be dramatically enriched if we could just get the IoT data into them. We're not trying to build software for redoing ERPs or asset change management, any of those kind of large segments or customer relationship. What we want is to enrich those tools with the data coming out of IoT. If we enrich that the right way, then that's going to increase the ROI of our tool and the other tools. So they're basically getting a double bang for their buck. They may have already been able to invest in that service flow work tool, but now that service flow work tool is automatically going to know 4 or 5 more things so that when they do send someone out to fix it, they have the right part. They know how long it's going to take. They know exactly how long the outage is going to be. So then now their customer success is higher. Basically we're just enriching those systems so there's more value in them. You certainly can, we're an application, we can build lots on us, but our real vision is that we will optimize the flows that are in these businesses today.
This is very close with my view on IoT, that IoT is just an enabler. IoT by itself does not provide any business value on its own. It is enabler that provides that real-time insights and real-time execution logic, and then you need to have all of those business domain systems. As you said, ClearThing is not trying to replace, let's say, CRM, right? But you can feed data directly into the CRM if that would be required. So maybe you could give us some real-life examples of customers integrating ClearThing into specific systems.
Yeah, I mean, an easy one is with things like ServiceNow, right? So ServiceNow is a kind of a ticketing system. It's how people put their workflow for resolving issues internally. Does a lot more, right? It's a huge tool, but a lot of folks in our customer space are using it for that workflow management and support, dispatch. Tivoli makes one. So there's certainly more in that category, and we integrate with those. So what that means is if we have a remote location, I'll pick a pump. If that pump suddenly has a symptom where the flow is much less expected than the RPMs and the power drain, right? So we understand how to get those data points. We understand how to say if the RPMs are this high, the wattage is at this above this level, we should see a flow of water that is a certain pressure. If those are off, we can immediately open the ticket into that system. Today, it happens to be when the person drives by and they see the pump, they're like, man, this thing ain't working right. And they open a ticket in ServiceNow, and then somebody calls that guy and says, hey, how's it sound when you do such and such? And then they open the HMI and they push some buttons and they say, maybe it's doing this. So we've got this accurate truth instantly before any human had to see it. That goes into the system, and now maybe there's enough data that they immediately know 90% of the time when this symptom, it means there's a bad seal ring. And so they can immediately drive that truck out and replace that pump, that part in that moment with the correct information. So really what you see is the same people are doing these jobs, the same expertise, but you're shortening that life cycle, that business process that probably still involves notepads and handwritten things and walkie-talkies, and you're turning that into somebody just shows up and fixes the part. We have that holy grail. Our homes will do that one day, and our home devices may do it, but it's highly more valuable for working out in West Texas and rural, and you drive 3 hours every time to do anything, right? In these non-urban areas, being able to automatedly understand what's going on and reacting to it. But all of that workflow, sending that person out, that exists in these other tools today because that's what they've built. And so now if you can just enrich that, you just shortcut all this time to get the same great outcome from both pieces of software.
When I first heard about connected fridge, I thought that this is just a stupid idea because I don't have to use my mobile phone to check if I've got milk in my fridge. But then I was at the conference and someone said, okay, but what if you own restaurants? Then all of a sudden it really makes sense to know what you've got in every location available. And I realized that I was looking from the product perspective, not the business case perspective. And what you said about pumps is exactly the same, right? If I've got a single pump, I don't probably need all of that. But what if I'm the operator of pumps or I've got other assets that are remote and I need to measure them remotely and I need to do things called predictive maintenance? All of a sudden, that really creates tons of value. And Pump is a great example of digital twin. So could you explain the digital twin concept, what it is, and why it is often misunderstood by a number of developers?
Well, I may misunderstand it myself, Lukash. I always try to say what I think it is because it's sort of like agile development. I'm not sure anyone knows how to exactly do agile development, but we all do it our own ways and it kind of looks the same. For me, a digital twin has to include being connected at some point to real live data streams. I think if you were to read the Wikipedia definition, it would basically say a digital representation of a real life element. Well, I've been playing video games that had cars in them for years and years and years, and I don't think Rad Racer from when I was a kid is actually a digital twin, right? So for me, yes, I may have this thing that is a digital representation, but I need it being hydrated with information coming off of sensors, coming off of different locations to tell me about what it is. So for us, a digital twin is an asset of some kind. We're talking industrial. It's an asset in the field. It's in the home, but it's a thing that now is being populated with live information, real information coming off of the sensors over the internet, over whatever protocol to get there for me to understand what's happening with that device. Now you can take it further. You can try different things against it, make that digital object represent the real one so that you could show it turning off and on and you practice different processes. But in the end, to me, if we're going to have a digital representation of a physical device, that we want live data coming against it as well. So connected digital twin is what we see. And if you think about what IoT is, IoT often is confused. Is it a bunch of sensors sending data, or is it a physical thing we want to look at that has sensors feeding it? To us, they are separate. The device is separate from the digital twin. The digital twin is comprised of many things, all describing it and letting us understand it. And potentially our digital twins are connected to each other. The building has rooms and the rooms have different pieces of furniture, right? All of that makes different types of digital twins that comprise the overall understanding for us of the physical world from the digital view.
I think that's a great definition. I agree with you that this term is often overused and it's not that clear what it is. I totally agree with you. Though I think that the intent that you described, this is exactly what I think about. ClearBlade, we've got intelligent assets, which is in a way implementation of digital twins, but it is way more than just a theory because you've got working solution. So could you explain what the intelligent asset is and what business value does it provide?
Yeah, so one of the things, we talked in the last session about how we built this middleware for connecting all these devices. Even this session, we talked about edge processing and protocol agnosticism, and that's all great. But in the end, most people want to open their phone, open their computer, and see the asset and what it's doing. And we basically worked with customers many years ago, and we watched them say, I have a very specific application. I want to see where my slag haulers are driving around my mine, right? And then there's someone else said, I want to know if my railroad crossings are working correctly. And someone else said, I want to know where all the equipment is to fix an airplane. And someone else said, I want to know if all my pumps are running in the right way. And we suddenly realized everybody's solution, while seemed completely different to them, it was actually this asset being populated by lots of data feeds. And then they wanted to write a series of rules around it. When the rules were satisfied, they wanted some event. They wanted to know what happened. And they wanted to take actions. And they wanted to work down those actions and send alerts and stuff. So, once we kind of said, wait a minute, why are we building the same thing? The data model was the same. The flow was the same. The requests were the same. The only difference was what was it named? And then, what attributes were made it unique. And so we went that path and realized there's an application here for end users. If we do this well, we can actually meet the needs of many, many, many verticals with a single application. Now, some applications need very specific UI, right? They need designers spending months and months making the perfect screens because they're for end users who have very demanding experiences. That is not true, in my opinion, of about 90% of IoT use cases. Most IoT use cases, the end user understands, my asset's a truck. I go look at my truck and I can see my data and I see so there's a lot more tolerance in the space. And that's what intelligent assets is. It's giving you something out of the box that will let you either load in the domain if somebody else has built, locomotives already, or it will let you create the new type of locomotive in there and then have that data come up and build the relevant rules. So it's tremendous business value because for a lot of people who have IoT projects, they really just have a business unit that wants this application on the other end. So this basically speaks to the business unit who says, today I've got these 5 things. I've got generators, I've got propane tanks, and I've got 5 motors. But we also know we're going to want a way to also add in 2 or a couple compressors as well one day. This one application says, yes, this is what we're designed to do. You can get to business. You can see this right now. You can write your rules and alerts. You can update with your service flow tool. And suddenly the whole journey of IoT is shortened. The journey is really to get to that application, and we can give that out of the box, obviously leveraging all of that deep technology we've talked about for the last couple hours.
Let me know if I get it right. You said that the business unit can create an intelligent asset on their own, so they do not need any IT support. Is that correct?
Yeah, I mean, that's absolutely the goal. I mean, there's still maybe a net new protocol nobody's ever heard of that we want to bring in, right? So we have to go play at that lower level. But being able to represent your business elements and attributes, that's what this application is for, right? If you look at the marketing, it'll say no code, and that's really about letting the business user define what they want out of IoT.
From my experience, no code only works when the actual code base below is at the highest level. You've got those various levels of abstractions and various designs, like the data schema designs, that you find are sufficient for all of those use cases, and you expose an intuitive way for the customers to add attributes, to customize the logic and maybe the look and feel of the intelligent asset. But under the hood, this intelligent asset uses the same data structure as of everyone else, which is a huge point because it allows you to scale. You don't want to create a custom object for every single customer, or actually for every single device of every customer. You want to have that unified data set, and this is what you just described. I think that's a great approach to it.
Yeah, and you actually talked about something else. You know, there's code, right? And then there's kind of like a faster code helpers. We use that with our IDEs. And then there's this whole segment of, kind of like drawing connectors and stuff. And I worked on those tools. And I talked in our last session about how I went from working in a lab and then going and helping customers. And I learned my customers, they were good at code, but then they would just wanted the application to work, And so low code for Clearblade is very kind of murky of, will it really solve these production problems? So we've worked incredibly hard to say, give the developers their tools and give the business user their tool with no code. And then that middle is an unknown middle. Who are you serving in that case? So we try to be very clear on our customers for both these applications. And the nice thing is most large enterprises, they have business users. They still have IT, so they can take advantage. They can appreciate those other tools, but their business user can get value and get served right out of the gate with intelligent assets.
So within even the same organization, you provide different set of tools for IT department and different set of tools for business departments, right? And Clearblade is the framework that joins all of that together and provides the business value out of the data and out of the logic that those experts in then their specific domains actually embed into the system. Is that correct?
You got it.
That's a great approach, and I'm not really sure if this is something that I've seen anywhere else, that you provide both of those SDKs, so to speak. SDK is, of course, term from the IT, and also the no-code interface for the end users. And I want to provide a very short look into the future, and that future is being the next episode that we're going to record, is the Gen AI chatbot that basically takes the whole concept of no code a totally different level. Could you explain that very briefly without spoiling everything for next episode?
Yeah, so I'll say actually AI is great in intelligent assets because AI is hard and AI is made simplified if you put it in the context of something like intelligent assets, whether it's Gen AI, which creates stuff. There's a whole activity of creating your airplanes, of creating your pumps, right? What can Gen AI to do to speed that time up? That's configuration time. That's time to value. So definitely you could see where a company like Clearblade, we've already launched it, right? Our first phases of being able to generate the elements of the IoT solution you want to look at. You'd be able to give it very simple prompts that you as a business user understand, right? We're trying to serve that business user in this tool. So you can say the terminology, the language at which you use it. You can put all of that into your basically generation request, and then it can build up the rules that match the What does too hot mean? Well, too hot means in this industry over 10,000 degrees. So the rule is set to 10,000 degrees. Too hot in the refrigeration industry might be 22 degrees, right? And so the variables of the language and the generation that you have to do for each domain can be pulled because there's this wealth of knowledge of understanding of these domains. The Gen AI is going to go a lot further. If you think about it, the ability to do some of this harder stuff we talked about with being device agnostic, all of that as well is documented somewhere. So can we take that next step and really decrease that time for those developer activities as well? So Gen AI is all over intelligent assets, the digital twin. I would say AI is all over that as well. So we're actively doing that today, predicting attributes. You have 10 attributes. There's one that's influenced by the 9 others. They're features of the 9 others, or the 9 others are features of it. So if you can automatically make a prediction versus actual, think what the rule could be, right? Now you're saying predict the solar power generation based upon how cloudy it is, not just is it daytime. The rules become much more dynamic and very compelling with traditional AI. It's funny, AI is already old, but traditional predictions and neural nets and KNNs, that kind of stuff, decision trees, using that stuff against the data set is also very compelling. And because intelligent assets is all domain specific, we can hide all of these AI terms that confuse us. We can put, how is the model picked and championed and all of that stuff that you can have a whole conversation. All of that goes away, and it's just, here is the value, here is the prediction, here is the thing you want to show, and it gets created for you. So it really is, it's like we had wizards, I guess, in the 90s. Remember when we would all use our applications and we would open our wizard and it would create, right? Our wizards are becoming true wizards, right? They're artificial guys who are behind the scenes putting this stuff together.
Could you share the most complex intelligent asset created by your customers? Just out of curiosity, what was that and how it provided the business value for them?
So there's 2 types of complexity that we bump into. Sometimes we bump into a huge hierarchy, right? And we allow you to relate your assets together. So we have customers with hundreds of buildings, campuses, and then they are basically trying to understand energy usage at many, many different levels. So while they have power measurement sensors all over, ultimately they're rolling this up to get an understanding of what's happening on each floor, on each building. They're running against predictions of previous historicals to see what they're going to spend for the month. They're trying to hit initiatives for power saved. And so ultimately they'll be able to try to take actions earlier in a month to reduce the overall spend, find waste in their system. They're just doing it for energy and water. So it's not like there's a ton of attributes, but there's a tremendous amount of complexity in relationships and rolling that data up and getting the overall view. That one's fascinating. What's cool about that one is all we're doing is water and energy right now, but there's so much more in the building, the lighting, the occupancy, all this other stuff that's going on, which was where they're going to go. So to me, it's pretty fascinating. They're designing to structure intelligent assets that can do this first level. ROI is tremendous with just this water and energy management, but ultimately they're going to be able to take this solution and serve many, many stakeholders, from the servicing of the building to the energy management of the building to the financial operations of the building. All of that is being fed by this one application. That's one that's complex. And then we go another direction and we have railroad crossings as a good example of, there are potentially thousands of attributes on one asset itself. So it's not just the arm up and down, but there's many different pieces of equipment out there making sure safe operations are going on. If you've ever seen a train go by, maybe with 2 tracks and maybe it's split somewhere else, right? There is software that understands all that's going. It's amazingly complex, and each piece of software is doing different parts of it. And it's talking down the line, so they know trains are coming down the line, and all of it's going into back offices. So we've seen single assets that probably would have, 2,000, 2,500 attributes on them of different things that are important. We've seen it in a couple other types of assets as well. And then there's lots of derived information you create. So we can call them calculated attributes. So you might just get this one value, but you calculate 7 or 8 more that are interesting and valuable. So to me, those get very large, and they're very correlated in what matters down the line. The business is complex. You think a railroad, you think a train is a simple thing and it's on one line, but then putting all those cars together, going the right speed, the mass of all of that, it gets very complex over time.
Out of curiosity, are there any limits of number of levels in hierarchy of intelligent assets or number of attributes you can assign, or customers can assign as much as they need basically?
Yeah, our vision is unlimited. There's certainly a point where it's too cumbersome to use, because how do you use 1 million attributes of one asset? And obviously we're using underlying technologies that have to be optimized for those use cases. So I'm sure you'll hit thresholds where it's not valuable or performant. But in general, we don't put any hard limits. Our goal is for you to be able to cross-correlate, define your own relationships. And define your own attributes as far as you need them.
I think that's huge, because I know a few big providers that actually have got really fixed number of maximal levels in the hierarchy and maximal number of attributes. And then if you want to bypass that, you need to basically custom develop some logic yourself, use some database, and essentially do all of the heavy lifting. So I absolutely agree with you that there is a limit that makes sense. Maybe right now, maybe in the future, AI will make that limit to totally different level. But by design, you do not constrain your customers in how they want to shape their inventory, right?
Yeah, we had a customer partner that was monitoring tank batteries that held basically methane gas. And in that space, there's plenty of applications that monitor tank batteries. The difference he saw was you'll let me monitor everything I want about it, and if I put new equipment, I can just add it. And he called it SCADA 4.0. And that SCADA is another term that's kind of like digital twins, where you know it when you see it, but trying to describe it can be difficult. But he's like, you've unlocked what is something that seems pretty common about SCADA, is it's only these 4 attributes is all you get to do. You've unlocked that into this solution can go anywhere now. We can extend it in the future. And so they called intelligent assets SCADA 4.0 for that very reason.
IoT should unlock all of those business benefits. And in order to do so, you need to have extremely solid framework in place. And I believe this is what you created. So let me summarize, because we actually traveled quite far away. We started from a single device, essentially explaining what the edge is. Then we talked about the security of the edge, how to manage when that edge is offline or maybe doing some critical operations. Then the protocol level, the backend, all the way to universal data structures and adding AI on top. So that was a huge scope of this conversation. But still, I've got that question for you. If you could deliver a single message to our viewers based on today's episode, what would that be?
Yeah, I think for us, our experience is intelligent assets is more often than not where people are trying to get to with their IoT solution. Maybe not for connected product makers who are making something very specific for their product, but for most people trying to build IoT in their enterprise operations. They want to see it, they want to understand it, they want to represent their data, they want to know the history, and they want to take rules that make actions. That structure, the ability to define your own digital twin in this one application, will massively shorten your IoT journey. We see it other places, right? And we know this tool is valuable for lots of other spots. But ultimately, intelligent assets gives that operator the ability to basically run their own IoT journey. And that is really, really compelling. That allows the IT folks that have brought this tool in to really serve business units without having to build applications.
Perfect. Thank you so much for this fantastic conversation, Aaron. It is a pleasure to talk with you as always. Next time, we will cover the hottest topic of today's world, which is the artificial intelligence and why AI is the killer app for the edge. We already had a sneak peek during today's conversation, but we will go way deeper next time. So stay tuned. Please put your questions in comments, as we will answer them during the live episode that concludes this video series. Till next time, I'm your host, Łukasz Malinowski.